Welcome back to the video lecture series for Introduction to AI Programming using Scala. In this video we continue talking about regular expressions. In the last video we introduced the concept of a regular expression and started looking through the API. We're going to continue looking through the API to see what we can do with our regular expressions. Remember that while we're going to be using Scala's regex class, and we can very easily convert a string to a regex in Scala, it turns out that this library here sits directly on top of the Java library, and so we want to see what the options for regular expressions are. So before we start talking about some more of these options, let's consider another possible application of this. So we looked at a regular expression last time that would do phone numbers. What about something that's a very simple example, an int regex? Okay, so I want something that represents an integer. What can an integer be? Well, an integer could be, for example, 1 digit, or it could be 2 digits, or 3 digits. It could also have you're technically allowed to put a plus sign, though most often plus signs are left off, but you might have a minus sign instead. How could we put that in our regular expression? Because we don't know how many digits we want. We do know there needs to be at least one, and then there's optionally plus or minus signs. So whereas the phone number, we knew how many digits there should be, for an integer we don't, and so we need to turn to the API and learn a little bit more about regular expressions to figure out what we can put in here. So the first part, which we don't necessarily need for our integer, additional functionality is boundary matches. So if you want to make sure that whatever you're matching starts at the beginning of the line, you put a caret at the beginning. Note that this is different than when you use a caret inside of a character class. Inside of a character class, it means negation of the character class. At the beginning, if it's the first thing in your regular expression, it means that your regular expression starts at the beginning of the line. If you put a $sign as the last thing in your regular expression, it means that it ends at the end of the line. And if little b is for a word boundary, so if you wanted to match something, but only if it was either at the beginning of the word or at the end of the word or a whole word, you could put a /b at the beginning or end of it. Non-word boundaries, and then some other options for boundaries. What will be more helpful for us for our example of the integer are the quantifiers. And the default quantifiers that we use, and the only real ones I want to talk about, or that I'm likely to have my students use, are the greedy quantifiers. So a quantifier tells you that some part of the regular expression, x here, x could be whatever you want, is going to occur some number of times. So in the case of a question mark, that implies that it happens one time or not at all. So this is a 0 or 1. A star means 0 or more times. A plus means 1 or more times. And in fact, at that point, you might think back, we've seen videos before where I have done something along the lines of this, str.split on space plus. Okay, so I've had videos where I do things like this, and this space plus is a regular expression. It turns out that when you call split, you're using a regular expression. If you ever ran into a situation where you tried to split on periods, you might have noticed that. Now I think about it, I think we missed that up here earlier in the API. We talked about \d. We didn't talk about the fact that dot represents any character. So that's why if I said that I wanted to match or do my splits on periods, and I do this, that is not what I really wanted. If I wanted to actually split on periods, I have to backslash my dot and then backslash. So probably the easiest way here would be to backslash the backslash. But what we actually did was also a regular expression and what this says, this uses the greedy quantifier plus, this says 1 or more spaces. And this helped us in the situation where we were splitting something up and perhaps the user put in 3 or 4 spaces inside of the input. If you don't put the plus, you'll wind up with a whole bunch of empty strings in your array, because it'll say, oh, there's a space, and then there's nothing, and then there's another space, and then there's nothing, and there's not another space. If you put the plus, it's a greedy quantifier, and it will take as many spaces as it can. And what the term greedy means for these quantifiers is that it will grab as many characters as it can as long as it still matches the whole string. So it won't grab so many that it doesn't match it, but it will grab as many as it can to match the whole string. And so that plus is one or more times. If you use curly braces, you can specify that something has to happen a number of times, or at least a certain number of times, or inside of a certain range. Now there are other quantifiers, the reluctant quantifiers and the possessive quantifiers, whereas greedy quantifiers take as many characters as they can to match, reluctant quantifiers take as few. Really, these are very rarely used for, I guess, in general, compared to the greedy quantifiers. Most of the time, you'll be dealing with the greedy quantifiers. The last thing that's worth pointing out here, because it's going to be significant to us, are logical operations. You've already seen if we just have two things next to each other, it's one followed by the other. You can also use a pipe to represent an OR. And so if we go back to our int here, well, our integer needs to have one or more digits. So that's a \d plus. Notice that the plus is going to be attached to the one element right in front of it. And so if I wanted multiple things in there, I would need to put them inside of parentheses to group them together. In addition to this, I have the possibility of there being a minus sign. And if we wanted, we could say this is a plus or a minus. You could say or a space. Note that another way of representing that would be the character class of plus minus space. It would give us the same thing. The or is generally more helpful if I have, so I want, for example, ABC or DEF. Okay, and then this would represent either one of, it would match either one of those two. If you're doing single characters, instead of doing the or, it's probably easier to use a character class. Okay, and I don't know why I would put the space there for nothing. You probably shouldn't start off your int with a space. So it can be, it's a plus or a minus, and the question mark represents 0 or more, so they might have neither plus nor minus. And then we have a digit followed by the greedy quantifier of plus, so as many digits as there are strung together. And this would be a reasonably good regular expression for matching integers. And so the last thing inside of the API, we saw the or there, are these parentheses which we can use to group things. The parentheses do more than just group things for us. They also produce capturing groups. And we'll see that when we start trying to use these regular expressions. They allow us, if you put sometimes you put parentheses around things not because you want to group them or you need to group them, but because you want to pull that value out of the regular expression and after you've done the match. So in this case, their example here, they're doing exactly that. They put these parentheses not because they want parentheses. They actually want 4 digits and a hyphen and 2 digits and a hyphen and 2 digits, but they want to be able to call back out after they do a match. They want to be able to find out what these 4 digits were, what those 2 digits were, and what those 2 digits were. And so that is the other reason for using the capture groups. So let's go back to our regular expression here, and something that I might want to do in this case would be I'm going to use 2 capture groups here, and note these capture groups are nested. So I have a plus or a minus, but I also wanted to capture just the digits, regardless of whether it is positive or negative. Maybe my application that I have, I want that type of information. Capture groups are numbered. The numbering starts at 1 when you access them through their number. And the number that you use is based upon the location of the open parentheses. So group 1 would be associated with that open parentheses, which means it's the whole thing in this example. and this open parentheses would be group 2, even though it's nested inside. And if we had something that was more complex, these things would be numbered, so this would be 1, this would be 2, the next open here would be 3, 4, 5, and 6. Okay, and obviously I'd want to have things inside of these, but the ordering is based completely upon the location of the open parentheses for an expression. So that's it for this video. We've kind of introduced all of the major concepts that we want in our regular expressions, and in the next video we'll see how we can use this in Scala to actually write some interesting code.